Hello and welcome to everyone. This is Neeraj Gautam. In our last class, we discussed about the flywheels and turning movement diagrams. We also solved some problems based on the flywheels. In today's class, we will discuss some numericals based on the turning movement diagram and flywheel also. So let's start the class with the numerical shown here. The turning movement diagram for a petrol engine is drawn to the following scales. The turning movement scale is 1 mm equals to 5 Newton meter, and the crank angle, when I move 1 mm on the crank angle axis, then it is equivalent to turning of 1 degree of crank revolution. So the turning movement diagram repeats itself after every half revolutions of the engine, and the areas above and below the mean turning movement diagram line taken in order are 295, 685, 40, 340, 960, 270 mm square. The rotating parts has an equivalent mass of 36 kg, and the mass and the radius of gyration is 150 mm. Determine the coefficient of fluctuation of speed of the engine when it is run at 1800 rpm. So the equivalent most rotating masses are given as m equals to 36 kg. The radius of gyration k is given as 150 mm. Simply it is 0.15 meters. You can determine the mass moment of inertia of the rotating components as mk square. Okay, and now to determine the coefficient of fluctuation of speed, n is given as 1800 rpm. The engine runs at the speed 1800 rpm. The corresponding omega value, that is 2 pi n by 60, which is equal to the 188.52 radians per second. These are the angular speed. Now, the area of turning movement diagram, which is the base represent the work done or the power. So the turning movement diagram area 1 mm by 1 mm is equivalent to 1 square mm area of turning movement diagram. We know that it is equivalent to the work done so 1 mm into 1 mm equivalent to the work done of 5 Newton meter into 1 degree. 1 degree means pi by 180 radians. Remember, here in t theta diagram, theta should be in radians. So I converted this degree into radians by multiplying pi by 180. So this pi by 180 radians. So 1 square mm is equal to 5 pi by 180. That means pi by 36 Newton meter energy or torque, energy or work is equal to 1 mm square of the turning moment. Now here in problem, it is given that these areas are above and below, above and below, above and below, above. Okay, so this is the above 685 is below, 40 is above, 340 is below, 960 is above, and 270 is below. So these are the areas. The areas above the mean torque line, this is your mean torque line. The energy corresponding to the mean torque line is E. So this is the positive energy, this represents the negative one. This is positive, this is positive, this is negative, this is again positive, and this is again negative. This energy diagram represents for the one complete cycle. Now, first of all, we determine the maximum fluctuation of energy delta E in this problem. For maximum fluctuations of energy delta E is basically equal to the maximum energy during the cycle minus minimum energy during the cycle. Minimum energy during the cycle. Now, let at A, energy at A is equals to E. Take this diagram with me. Here. So energy at B will be therefore at B, energy at B is equals to energy at A plus this area 295, and 1 mm square area represents pi by 36 Newton meter energy. So 295 mm square area represents 295 into pi by 36 Newton meter of energy. So this energy at place of EA, I will write its value, which is I assumed here as E. So this energy is E plus 295 pi by 36. Similarly, at B, after B, that is at point C, the energy will be at B minus this area energy, which is 685 times of pi by 36. Okay, so energy at B is equals to E plus 295 pi by 36 minus 685 pi by 36, and finally this energy at C is E minus 295 minus 685, that is 390. So it is 390 pi by 36. Okay, so this is EC. Similarly, ED, that is energy at point D, again we will add this 40, this area. So E minus 390 by 36 pi plus the 40 pi by 36 is added here. Again, this is minus, so it becomes E minus 350 pi by 36. The energy at point D is E minus 350 by 36 pi. So similarly, you can write energy at point E, which is as the ED, the energy at point D, minus this area of 340 pi by 36. I am writing in terms of energy. pi by 36. And if I subtract this thing from this, so 350 and 340 becomes 690. So energy at point E is ED minus 690 pi by 36. Again, it's E minus 350. ED is not ED, because I am substitute the value of ED as E minus 350 pi by 36. So ED at place of ED, E minus 350 pi by 36, 350 plus 340 is 690 pi by 36, which has the negative sign because here it is the negative and this is also negative, and this E comes here as E. Now at point F, the energy becomes, with the addition of this energy, that is 960. So at point F, I will write directly 690 has a negative sign and 960 has a positive sign. So 960 minus 690, it is becomes 270. So it is E plus 270 pi by 36. Okay, so energy at point F becomes E plus 270 pi by 36. Similarly, I can write for G by subtracting 270. So at point G, I will write E plus 270 pi by 36 minus 270 pi by 36. This is the area. If I multiply this area by this factor pi by 36, then I will convert this area into the energy. So this plus 270 and this minus 270 is become 0. So energy at G is equals to E. It is also equal to A. So the cycle is completed. The initial energy is equal to the final energy. Now you can compare the energies from all these relations, that what is the has a maximum value. Here you are adding E plus 295 times of pi by 36, and here E plus 270 pi by 36. So only two energies has a plus sign. So the maximum is at E, B, and the minimum energy is a subtraction from the E. Maximum subtraction from E, you will give you the minimum energy. So here the maximum subtraction of 690 pi by 36, which is the minimum energy. So from this comparison, maximum of all the energies is EB and minimum of all the energies is EE. So the maximum energy from the comparison, by comparing all E's, E max is equals to EB equals to E plus 295 pi by 36, and E minimum is EE, which is equals to E minus 690 pi by 36. Okay, 295 minus 695. So if I subtract these energies and find the difference between these maximum and minimum, E cancel out. 295 minus 690, so minus minus become positive. 295 plus 690, it gives you 985. 985 into pi by 36, as usual, Newton meter of energy, that is joules of energy in fluctuations. So the fluctuation of energy is this. Now we have to determine the coefficient of fluctuation of speed. Now the coefficient of fluctuation of speed, we know that CS is the coefficient of fluctuation of speed, which is equal to the which is related to the coefficient of fluctuation of speed, and delta E, that is coefficient of fluctuation of energy, is equal to the mk square omega square cs. Here, after the calculations of this 985 by 36 pi, we get approximately 86 joules of energy. If I substitute the value of delta E as 86 joules, m as it is given as 5, that is 36, into k is 0.15, and this is the square of k, into 188.52 radian per second, and also square of this radian per second speed cs, and finally value of cs is equals to 0.003 in fraction percentage fluctuation of speed, that is percentage cs equals to multiplying by 100, so 0.3% fluctuation of speed is there. In percentage it is 0.3, in fraction it is 0.00. So in this way we have to solve the problems based on the turning moment diagram. So we have to determine the maximum energy at the point at which the maximum energy occurs, the point at which the minimum energy occurs, by calculations of the energy like this, and hope can solve the problems based on the turning moment diagrams given in this manner. If you have any doubt or query related to this topic or in this subject, then share your doubts or queries on the given numbers here. Okay, thank you.